Hi dear students, welcome to PMSH classes. In this lecture, we are going to discuss some question based on lecture 2 to 8. So welcome to the lecture 9 of motion in a straight line. Without much delay, we will move on to the questions. Okay, so here is the first question. The question is, find the displacement and velocity of a body whose displacement is represented by x equal to t cube plus 3t square plus 2 at t is equal to 2 seconds. Also find the initial displacement and initial velocity. So the question is basically to find the displacement and velocity at two intervals. One is initial displacement and initial velocity, and the second one is the displacement and velocity at time t is equal to 2 seconds. Okay, so what is the given data? Whenever you get a physics question, you first write the given data. Okay, so what is the given data? They have given you the expression for displacement, that is x is equal to t cube plus 3t square plus 2. Clear? Now you want to find the initial displacement and the initial velocity. So what you have to remember, whenever they ask you about the initial quantity, okay, initial quantity means the quantity may be displacement, velocity, or even acceleration, whatever it may be. You can substitute the time t is equal to 0. Clear? So displacement and velocity at t is equal to 0 and displacement and velocity at t is equal to 2 seconds. So these two are what we have to find. So we will see how to find the initial displacement. Initial displacement. For initial displacement, the time will be 0. So write the expression x is equal to t cube plus 3t square plus 2. Okay. Now you put time t is equal to 0. What do you get? 0 cube plus 3 into 0 square plus 2. So the answer is going to be 2 meter. Suppose it is in SI unit, then you can say it is 2 meter. Otherwise, you say it is 2 units. Okay. So I just assume the quantities are in SI unit and I just substitute as meter. Okay, that's all. Now you want to find the displacement at a time t is equal to 2 seconds. Okay, displacement at t is equal to 2 seconds. So what is the equation? X is equal to t cube plus 3t square plus 2. Just substitute t equal to 2. That is 2 cube plus 3 into 2 square plus 2. So that is 8 plus 2 square is 4. 4 times 3 is 12 plus 2. So that is the answer is 22 meters. Clear? Now you want to find velocity. So you are given the question have given the expression for displacement and they ask you about velocity. So what is the theory you have to remember? Velocity is the first derivative of displacement, right? So we can say velocity is the first derivative of displacement, that is dx by dt. So what is your x? Your x is t cube plus 3t square plus 2. Am I right? Let me verify. Yes. With respect to time, you have to differentiate. So the answer will be dt cube with respect to dt plus derivative of 3t square with respect to dt plus derivative of 2 t cube. The derivative of t cube will be 3t square. I have already discussed the rules of differentiation, right? The constant 3 will be taken outside. The remaining will be derivative of t square, right? What is derivative of t square? That is 2t plus derivative of 2. 2 is a constant. What is derivative of a constant? 0. Okay, this is all we have discussed in the previous lectures. So what is the expression for velocity? The expression for velocity is 3t square plus 60. So this is the expression for velocity. Clear? Now you have to find the initial velocity. Initial velocity. For initial velocity, the time will be 0. So what will be the equation for velocity? 3 into 0 square plus 6 times 0. So our answer is going to be 0 meter per second. That is the initial velocity of the body is 0. Clear? The initial velocity of the body is 0. Now you want to find the velocity at t is equal to 2 seconds. So just substitute t is equal to 2 seconds in the expression for velocity. That is v is equal to 3t square plus 60. That is 3 into, sorry, 2 square, right? 3 into 2 square plus 6 into 2. 3 times 4 plus 12. 12 plus 12, that is going to be 24 meter per second. Am I correct? It is 24 meter per second. Okay. You just don't blindly follow me. You pause the video and do it yourself. If you get the same answer, then it is okay. Sometimes I may have some small calculation mistakes. So you can, if you note something like that, you can comment it on. Okay. So I hope the question is clear. Now we will move on to the next question. Okay. So here is the second question. The position of an object moving along x-axis is given by x equal to a plus bt square, where a is 8.5 meter, b is 2.5 meter per second square, and t is measured in seconds. Okay. Now the question is, what is the velocity at t is equal to 0 seconds? That means you have to find the initial velocity, and also at t is equal to 2 seconds. Okay, 2.0 means 2 seconds. Now the next question is, what is the average velocity between t is equal to 2 seconds and t is equal to 4 seconds? So you are supposed to find the average velocity. Okay. So let's write the given data. Given data. The expression for displacement is given to be a plus bt square, where a is given to be 8.5 meter, b is given to be 2.5 meter per second square. Okay. Now you want to find the velocity at t is equal to 0 seconds, the velocity at t is equal to 2 seconds. Okay, this is question mark. And also you have to find v average. V average means average velocity between t equal to 2 second and t is equal to 4 second. So these are what we have to find. So this is the summary of the question. Okay. So here is a summary of the question. Now you want to check about velocity. So how to find the velocity? We know that velocity is the first derivative of displacement. So you differentiate the expression of displacement, that is a plus bt square with respect to t. Clear? Since there is a plus sign between them, we will separate it. So derivative of a with respect to t plus derivative of bt square with respect to t. We know a is a constant, right? The value of a is 8.5 meter, which is a constant value. We know that derivative of a constant will be 0 plus b will be taken outside. Then you have derivative of t square. So the answer is going to be 2bt. Okay. So the expression for velocity is 2bt. Expression for velocity is 2bt. Okay. Now you want to find velocity at t is equal to 0 seconds. So v at t is equal to 0 seconds. So v will be 2 times b times 0. So the answer is going to be 0 meter per second. So velocity at 0 seconds or initial velocity is 0 meter per second. Okay. Now we want to find velocity at t is equal to 2 second. So that is v is equal to 2 into b. What is the value of b? B value is 2.5, right? So just put 2 into 2.5 into, what about the time? Time is 2 seconds. So just put 2. So the answer is going to be 2 into 2.5, 5. 5 times 2 is 10. So it is the 10 meter per second. Clear? So we have completed the first two questions, that is velocity at t is equal to 0 second and velocity at t is equal to 2 second. Now you want to find the average velocity between t is equal to 2 second and t is equal to 4 second. Okay, so let's see how to find that. So we want to find v average between t equal to 2 second and t is equal to 4 second. So let us first write the equation for average velocity. The equation for average velocity we learned is total displacement by total time. Clear? So first we have to find the total displacement. So we will see how to find total displacement. Total displacement. So the expression for displacement is x is equal to a plus bt square. We want to find the displacement at t is equal to 2 second, and also we want to find the displacement at t is equal to 4 second. Then what you will do? You will subtract the displacement at t is equal to 4 second. Okay, or you will subtract the displacement at t is equal to 2 second from the displacement at t is equal to 4 second. Clear? Okay, we'll do it. So it will be more clear. We'll do it. So let's find displacement at t is equal to 2 second. So x is equal to a plus bt square. What is the value of a? The a value is 8.5 meter. 8.5 plus bt square. What is b value? B value is 2.5. 2.5 multiplied by t square. What is our time? The time is 2 seconds, right? So we have to put 2 square. So this is going to be 8.5 plus 2.5 multiplied by 4. So it is 8.5 plus. What is 2.5 multiplied by 4? That is going to be 10. So the answer is 18.5 meters. 18.5 meter. That is the displacement at t is equal to 2 seconds. Now let us find the displacement at t is equal to 4 seconds. Again you have to use the same expression. X is equal to a plus a is 8.5 plus bt square, b is 2.5. The t square changes to be 4 square. Clear? So this is 8.5 plus 2.5 multiplied by 8. So that is 8.5 plus 20. Clear? 2.5 multiplied by 8 means 20. So this is going to be 28.5 meters. Clear? Now you want to find the displacement between, okay, total displacement between 2 second and 4 second. Between 2 second and 4 second. So how to get that? So that displacement, let's put it as S. S is equal to displacement at t is equal to 4 second minus displacement at t is equal to 2 seconds. So that is going to be 28.5 minus 18.5. The answer is 10 meters. So let us write V average is equal to total displacement. Total displacement is 10. Between 2 seconds and 4 seconds is 10 meters. And what is the total time taken? Time taken is 4 minus 2. Right? 4 minus 2. So that is 10 by 2 is equal to 5 meter per second. So that is the average velocity. So the average velocity is 5 meter per second. Clear? So the question is very simple. Some of the parts of this question is similar to the previous question. They have given you a expression. You have to calculate the velocity at two different time intervals. So what we do? We done the differentiation of the displacement expression to get the velocity expression. Then we substituted t is equal to 0 and t is equal to 2 seconds. Now something extra is about average velocity. And we know that the equation for average velocity is total displacement by total time. The total displacement is between 2 second and 4 second. So what you will do? You will find the displacement at 2 second. You will find the displacement at 4 second. Then you will subtract the displacement of 2 second from the displacement of 4 second. Clear? Then you will get the total displacement between those time interval. Then what is the total time taken? It's just 2 seconds, right? The total time taken to make this displacement 10 meter is just 2 seconds. You just divide them to get the V average. Okay. Now here is the next question. The speed time graph of a particle moving along a fixed direction is shown in figure. Obtain the distance traversed by the particle between t is equal to 0 seconds to t is equal to 4 seconds. And also we have to calculate the average speed of the particle over that interval. Okay. So let's see how to do this. So the given graph is actually a speed time graph, and they ask you about distance traversed. So we know that distance is actually the area of speed time graph. Am I correct? Distance is the area under speed time graph. Distance is the area under speed time graph. So what we have to do? We just want to calculate the distance between time equal to 0 to time equal to 10 seconds. So what you will do? You will calculate that area. You will calculate this area. You will calculate this area. So you can say that the distance, I'll just change the color. Distance is equal to area equal to half into base into height. That is half into, what is the base? Base is 10 seconds, right? 10 seconds multiplied by, what about the height? The height is 12. Clear? We know that what is height, right? This is what is the height. So this height is going to be this value, that is 12. Clear? 12. So the answer is 12 meter per second, right? Second will cancel. 2, 10 cancel to be 5. Clear? 5 times 12 is 60. So what is the distance? The distance traversed or traveled is 60 meter. Okay, distance traveled is 60 meter. Now the next question, what is the average speed of the particle over the interval? How to find the average speed? How to find the average speed? Average speed is nothing but total distance by total time. What is the total distance traveled between 0 second and 4 second? That is what we found, 60. And that is the total time taken is 10. So it is 6 meter per second. So the average speed is 6 meter per second. Clear? The average speed is 6 meter per second. So it's a straightforward question. Nothing much to think about it. Okay, if you know the theory very well, you can do it. You can watch my lectures on all these concepts. Okay, we will move on to the next question. So the question is, the acceleration time graph of a body starts from rest is shown below. So the first point you have to mark is body start from rest. Okay, that means the initial velocity is going to be 0. The initial velocity going to be 0. Now what you have to find? Draw the velocity time graph using the above graph. So using this graph, this is the acceleration time graph, right? This is the acceleration time graph. You want to draw the velocity time graph. Now let's see what is a B question. Find the displacement in the given interval of time from 0 to 6 seconds. So 0 to 6 seconds you want to find the displacement. Now what is the C question? Find the distance traveled in the given interval of time from 0 to 6 seconds. So these are the questions. So first of all, we will draw the velocity time graph. Okay. We'll draw the velocity time graph. So let's mark time on x-axis and velocity on y-axis. Okay, here it is 0. So let's see. According to the question, the body have a initial velocity 0, right? The body have a initial velocity 0. So we will mark the point here. Clear? Now we want to calculate the velocity at t is equal to 3. Okay, you have to calculate the velocity at 3 equal to, because till 3 seconds the velocity does not change. You can observe this graph. You can observe this graph. What is the specialty? From 0 second to 3 second, the acceleration of the body does not change. The acceleration of the body is 4 meter per second square. So you will calculate what is the velocity at this time. That is, at time is equal to 3 seconds. What you have to calculate the velocity. So what is the expression for calculating velocity? What is the expression for calculating velocity? Velocity is equal to u plus at. The initial velocity is 0. The acceleration is 4. Am I right? The acceleration is 4 meter per second. The time is 3. 4 times 3. That the answer is 12 meter per second. Clear? So at time equal to 3 second, the velocity is going to be 12 meter per second. So that's the point. So let's draw the graph. So the graph is like this. Okay. So the velocity is increasing. Velocity is increasing with a constant acceleration. That is 4 meter per second square. Now we want to calculate what is the velocity at 6 second. Okay, velocity at 6 second. Because from 3 second to 6 second, the velocity does not change. But sorry, velocity not, acceleration does not change. The acceleration is minus 4 meter per second square. You can observe here. The acceleration is minus 4. From 3 to 6, the acceleration is minus 4. So you will calculate the at velocity at t is equal to 6 second. So let's see how to calculate. V is equal to u is 0 plus acceleration is, you can take the acceleration to be minus 4, but the acceleration change in between, right? So what you will do, there is a changing acceleration. So we'll calculate the velocity from 3 to 6. That's better. Let's calculate the velocity from 3 to 6. Let's erase this. We will calculate velocity from 3 to 6. So let's see how to calculate the velocity from 3 to 6. Okay. So the velocity is going to be u. What will be our u? See, from 0 to 3 second, when it is at 3 second, the velocity is 12 meter per second, right? When it is at 3 second, the velocity is 12 meter per second. Now we are calculating the final velocity at t is equal to 6 second. So what you have to do? Your initial velocity will become 12 meter per second. Clear? Your initial velocity will become 12 meter per second because you are starting from 3 second. At 3 second, the velocity is 12 meter per second. So what is your initial velocity? 12 meter per second. Plus A is minus 4. The time interval is 3. 3 to 6, right? So the time interval is 3. So the answer is going to be 0 meter per second. So what can you observe? At 6 second, okay, at 6 second, the velocity becomes 0. At 6 second, the velocity becomes 0. Which means the velocity is actually decreasing at a constant acceleration. The velocity is decreasing at a constant acceleration. Acceleration or deceleration? Better to say deceleration. Clear? So this will be the velocity time graph. I hope it is clear. This will be the velocity time graph. Now, let's think about the B question. B question. So what was our B question? Find the displacement in the given interval of time. So what can you say? Displacement is area under VT graph, that is velocity time graph. So here displacement is going to be half into base into height, that is half into, what about the base? Here you can see the base is 6, right, and the height is 12. So it's going to be 6 times 12, that is 3 into 12, which is 36 meters. So that is the displacement. Now let's observe what is the C question. The C question is, find the distance traveled in the given interval of time from 0 to 6 seconds. So again distance. So here distance is also area, right? Area under graph. Area under VT graph. Okay, but I have told you what is the difference, right? I have discussed the concept in a previous lecture where we are finding a scalar or a vector quantity from the graph of another physical quantity. So all of you please watch that part. Okay, so distance is area under VT graph. So here again the distance is going to be half into base into height, half into 6 into 12, 36 meter. So here the displacement and the distance are same. There can be question where displacement and distance will be different values. Okay, so you have to practice more number of questions. Now let's see another question. The displacement time graph of two bodies A and B are shown in the figure. So here is a figure. The figure is about displacement time graph. Okay, the ratio of velocity of A to velocity of B. So you're asked about the ratio of velocity VA by VB. So this is a displacement time graph, right? How to get velocity from displacement time graph? We have already told this point. Velocity is slope of ST graph. That is displacement time graph. So you want to find the slope of given displacement time graph. The equation for slope is tan theta, tan theta, and the angle theta is given in the figure. The angle theta is given in the figure. Okay, so we can write VA by VB as tan theta A by tan theta B. What about theta A? What is your theta A and theta B? This is your theta A and this is your theta B. So that is tan theta A is 30 degree. Tan 30 degree by tan 60 degree. Tan 30 is 1 by root 3 by tan 60 is again root 3. So that is 1 by root 3 multiplied by root 3. Your answer is going to be 1 by 3. So we can say that VA is to VB is equal to 1 is to 3. VA is to VB is equal to 1 is to 3. Clear? The question is very simple. The only concept that you are using here is velocity is the slope of displacement time graph. Okay. Now we will come to the last and final question. The displacement time graph of moving particle is shown in figure. The figure is about displacement time graph. Now let's see what is the question. The instantaneous velocity of the particle in negative at that point. Okay. So we want to find the point. Here there are some points marked on this graph, right? Point C, point D, point E, and point F. So we want to find at which of these points the velocity, instantaneous velocity is going to be negative. Clear? So we know that the same point, slope is the slope of displacement time graph is velocity. Clear? You are going to use the same point. So I'll draw the graph here again. So here they mark displacement, here is time. The graph is somewhat like this, right? This point is C, this point is D. Here they have given the point E, this is F. So we want to see the slope at C. We will find the slope at D, we will find the slope at E, and we will find the slope at F. Where the slope is negative, there you have the velocity as negative. Clear? Because velocity is the slope of displacement time graph. So let's see how to find the negative slope. How to find the slope at C? How to find the slope at C? We have already told that to find the slope at a point, you have to draw a horizontal line and you want to draw a tangent. So this is the tangent through the point C. This will be the tangent. This is our horizontal line, that is HL. So our angle will be always measured from horizontal line to tangent. That is, angle is measured in the anti-clockwise direction. The angle measured in the anti-clockwise direction is positive. So this angle theta is going to be, theta C is positive. Therefore, slope at C will be positive. Therefore, velocity of C will be positive. I hope it is clear. The angle at C is positive. Hence, MC is tan theta C, right? According to equation. So, MC is positive. So, velocity is positive. Let's find another point. Let's do another point. We will draw another point. We will find at point D. Okay. So, at point D, you will draw the horizontal line. So, this is the horizontal line. Then you have to draw the tangent. The tangent is also the same, right? The tangent is also the same. So, you can see that the angle is 0. The angle is 0. So, there is no slope because it is parallel to x-axis. Okay, tan 0. Sorry, you have tan 0 to be 0, right? M is equal to tan 0, right? Tan 0 is 0. So the slope is 0. Clear, the slope is 0. Hence the velocity is 0. So at point D, the velocity is 0. I hope it is clear. V is equal to 0 at D. Now let's see about E. Now let's see about the point E. So what you will do? You will draw the horizontal line at E. You will draw a horizontal line at E. This is your horizontal line. Then you had to draw the tangent. You had to draw the tangent. Now you have to start measuring the angle from horizontal line to the tangent. So this angle is measured in the clockwise direction. Clearly this angle is measured in the clockwise direction. If an angle is measured in the clockwise direction, then that angle is going to be negative. So at point E, the angle is negative. Since the angle is negative, the slope at E will be negative. Slope at E will be negative. Hence, you can say that the velocity at E is negative. Velocity at E is negative. So, the answer for their question, what is the answer for their question? It is point E. It is point E. So, at this point E, the slope is going to be negative. Hence, the instantaneous velocity of the particle will become negative. Okay. So again, in the next lecture, we will be discussing about acceleration, negative acceleration, uniform acceleration versus non-uniform acceleration, and also about instantaneous acceleration. So it is going to be a exclusive lecture about acceleration. Okay, so see you in the next lecture.